Hello everyone, in this video I explain applications of Newton's second law, Parachutist. Let us start. What are forces are there on that Parachutist? At start, just we have the weight. So the weight equals mg. The acceleration is acceleration due gravity. So here, just we have a big force. That big force is the weight, acted downwards. So this is the big force, acted downwards. So the force is the force of gravity, Fg, which is the weight. And the acceleration is the acceleration of gravity. In the first one, so the acceleration equals g, approximately 9.81 meter per second square. This is at start. No air resistance. After that moment, the velocity increases. So the drag force and the air resistance apply. Because the drag force proportional to the velocity. When the velocity increases, the drag force increases. That drag force, it is a force in fluid. So the air is a fluid. So the force is in a fluid. The fluid, it means liquid or gas. The air is a fluid. So the resistive force in air is called viscous drag force or drag force or air resistance. That air resistance increases as velocity of parachutist increases. So in this moment, we have two forces act on parachutist. The weight acted downwards and the viscous drag upwards. But in this one, still that force downwards is bigger than the forces upwards. So this is the forces upwards. So this is the viscous drag and this is the gravitational force. When the velocity increases of the skydiving, the viscous drag increases at the moment when they are equal. So in this moment, this is still Fg greater than Fd. In this moment, Fg equals Fd. The weight equals the drag. So in this moment, the two forces are equal. Fg equals to the viscous drag force. So they are equals. In this one, the acceleration equal to 0. And it moves with terminal velocity. So in this part, we have here terminal velocity. What do you mean by terminal velocity? It means constant velocity. What about the Newton's second law? Newton's second law told us that the resultant force act on the object equals the mass multiplied by the acceleration. M is the mass in kilogram, A is the acceleration in meter per second square, and the net force is in Newton. In the first case, just the weight. So when we apply Newton's first law in the first case, so F equals ma. F, it is that gravitational force, equals m. M, it is the mass, and A is g. So this is Newton's second law at the start. In the second part, Fg is greater than Fd. So the net force, the sum of F equals ma. So we write Fg, the gravitational force, which is the weight, minus Fd, the viscous drag force, equals ma. Or we can write the weight minus d equals ma. So this is Newton's second law. The acceleration in the second part less than the acceleration due gravity. So the acceleration less than 9.81. In the third part, when the weight equals the drag force, when Fg equals Fd, viscous drag force, the resultant force or the net force equal to 0. So the sum of F equals 0, and this part is the terminal velocity. So the acceleration equals 0, and this is Newton's first law, because the net force equal to 0. Now let us see that motion on a graph to explain what happened to the parachutist. Let us see the graph of velocity time for the parachutist. At start, just the acceleration due to gravity, so the forces act on the parachutist, just the weight, and it moves with acceleration 9.81. The acceleration is constant at beginning, so from 0 up to 5 in this interval, from 0 to A, it moves with acceleration due to gravity. We can get that acceleration from the slope, or it is constant. For that reason, it is a straight line. So from O to A, just the acceleration equals G. It is a straight line because G is constant. We can calculate the distance traveled in this interval. So the distance traveled in this interval, S equals the area under the graph. It is a triangle, half times base times height. The base is 5, so it's a half times 5, and the height is 20. So half times 5 times 20, half times 20, 10, 10 times 5 equals 50, so 50 meters. So it moves 50 meters with acceleration due to gravity 9.81. After that part, the drag force applied, and the drag force increases gradually, but the weight is constant. So the acceleration is not constant. So in this part from A to B, the acceleration is not constant because it is a curve. We can get the acceleration at any moment by drawing the graph. For example, if we need to get the acceleration at 10, to get the acceleration at 10, we draw perpendicular line at 10. At this point, we draw the tangent to the curve. We find the slope of that tangent, so the slope of that tangent at this point gives us the acceleration when the time is 10 seconds. So we complete this triangle. So we complete this triangle. We can get the acceleration in this moment when the time equals 10 seconds. The acceleration is the slope is vertical distance, or the acceleration is V2 minus V1 over T2 minus T1. So the acceleration in this, at this point, the acceleration equals V2, it is 35, minus V1, it's 25, over T2, we count here how many dashes, so let this point is 14, and this point is, okay, 7, so we say it is 14 minus 7. It's 1.4 meter per second squared. So the acceleration at t equals 10 decreases from 9.81 meter per second at A to 1.4 meter per second squared at the time 10. That acceleration decreases gradually. Why? Because the air resistance, the viscous drag force increases, but the weight is still constant. Then at the point B, the acceleration is 0 because the weight equals the drag force. In this interval from B to C, it moves with the skydiver moving with terminal velocity. So the acceleration equals 0. At the point C, parachute open. When the parachute open, what will happen? In this, the drag force, it will be more than the weight. So the acceleration is negative. So the acceleration is negative. So this is the direction of acceleration, because the resultant force upward, because the drag force is greater than the weight. So the direction of acceleration is upwards, but it moves down, so the velocity is down. Because the velocity is opposite to the acceleration, the skydiver moving with deceleration. So the velocity decreases gradually. And then from C to D, it moves approximately with constant deceleration, because the acceleration is negative, so deceleration, and then deceleration, okay, not constant, up to the point E, the velocity decreases, and then it will be reached to another terminal velocity less than the first terminal velocity, slower than this. So from part E to F, this is the second part of terminal velocity to land at the point F. So this is the movement of parachutist through the graph, and the forces act on the skydiver. I hope you understand this topic. Thank you.
My dream is to fly over the rainbow so high. My dream is to fly over the rainbow so high. Tried to